Hello friends, welcome to this lecture of information theory. In this lecture, today I will discuss the concept of self-information. In order to understand the concept of the self-information, we have to understand some certain facts. Here, I am considering three events. The event 1 says that the sun will rise from east tomorrow. Since it is a universal fact that the sun always rises from east, so it is not a new thing that the sun will rise from the east the very next day. So the amount of information obtained from this event is very less because it is a certain fact. But when I look at the event number 2, it says that the electricity will go off after 1 hour. Since it is unsure whether the electricity will go off after 2 hours or not. Since it is uncertain event, the amount of information derived from it gets high. Fine. But when we compare the event 3 with the previous two events, it says that there will be heavy snowfall in Sahara Desert in 2017. It is a known fact that in a desert, it is very difficult to predict whether there will be heavy snowfall in the coming future or not. So the occurrence of event 3 is you can say is typically unsure as compared to the previous two events. So the amount of information obtained from this event is more as compared to the event 2 or event 1. So from this conclusion, we can derive a simple expression that supports our discussion as well as that lays the foundation of the concept of self-information. So, as we have discussed so far, that as I have told you that the amount of information obtained from an uncertain event is very high. That means if I formulate it through expression, the expression would be like that IXI, that is information, is equal to logarithm of 1 by PXI. This is a expression which supports our entire discussion that the amount of the information obtained is always very high when there is a uncertainty of the occurrence of a particular event. So in this expression here x I is x1, x2, x3, that is a set of random events. Fine. And IXI is the amount of information obtained from the occurrences of random events. And PXI, random events XI, and PXI is the probability of occurrence of an event. Fine. So we can also write this expression as IXI is equal to minus log of PXI. Right? So these are the two important expressions on the basis of which the questions are asked in exams. So what may be the questions from this area? Let us check that. The question is, consider the rolling of a dice with following information. With following data, that probability of occurrence of event 1, event 2, event 3, 4, 5 and 6 all are equal to 1 by 6. Fine. Since there are 6 sides in a dice, so when we roll a dice, there is an equal chances of occurrence of each faces of the dice. So the probability would be 1 by 6 for each of the faces. So what we have to obtain, determine or simply compute the information obtained per bit for the occurrence of for the outcome of 3 phase 3 on rolling the dice. So this is a question that we may be provided in an exam. Then how we can conclude it? It is very easy to determine it. We can simply use a expression of self information as Ix is equal to log of 1 by Px. So this is the expression through which we can determine the value of the information. So what I have to do simply, I have to simply apply the information provided to us. Fine. So we can also write it in this this is basically probability is 1 by 6. Fine. Probability is 1 by 6. It is 1 by 6. So it can be written as log 2 by 6, and this can be calculated as log 2 raised to the power 2.1. Fine. You can represent it as in 2.1. So this becomes equivalent to 1, and the answer would come out to be 2.1, and the unit would be bit. So this is how we can solve the answer for a particular question. Fine. This is 2.1 bit. So what you have to understand here, that when the expression like this comes here, then we have to represent this thing in the terms of the power of 2. Fine. In the terms of the power of 2. If we can calculate it, it is observable that 2 raised to power 2 becomes 4 and 2 raised to power 3 becomes 8. Fine. So it is difficult to determine that the exact value of 6. So we can predict that the value, in order to obtain this value 6, the power that we have to take in, it would be around 2.1 or 2.2. I am taking it as a 2.1. So this entire equation becomes equal to the 1, and the answer that we obtain becomes 2.1, because we can simply see that we can also write this thing as log 2, and this entire thing becomes 1, and the answer would be 2 into 1, that is nothing but 2 in terms of bits. Fine. Clear? So this is how we can solve this problem. Now if I take consider the case of tossing off a coin with following data, and the data is the probability of occurrence, the coming out of head as outcome on tossing of a coin is 1/2, and the similar probability is also for the occurrence of tail. Fine. So now we have to compute IH, that is probability of head as the outcome on tossing of a coin. That we have to compute. So how we can compute it? We can simply use the fact that Ix is equal to log 1/px. So simply substitute the value here, and we will obtain the event as something like this. So it is very easy to predict that log 2 and 2 raised to power 1. In order to represent 2, I basically use power 1. This entire would become 1, and the answer would come out to be 1 bit. So few of the facts that you have to keep in mind while solving this problem is that if we want to solve a problem in terms of the 2 as a base, log 2 as a base, then the unit that is used would be bit. The answer would come in the terms of bit. When we solve a problem in terms of exponential as a base, the answer always comes in the terms of Hartley. Fine, in terms of Hartley. Sorry, it is basically nets. It is basically nets. Fine, it is basically nets. And when we solve the problem in the terms of the basically in terms of 10 as a base, the unit would be Hartley. Fine. So these are the basic units that we can obtain on solving a given term in given unit as a base of a log. Fine. One more thing that you have to remember here is that if we want to draw a graph for the self-information, what kind of the graph we can obtain from that? Let us check that. So the graph for a self-information, that is the formula that we are using, log 1/px, the graph that would be possible for this would be a non-uniform graph. Fine, a non-uniform graph would be obtained here. Fine, a non-uniform graph would be obtained here. Fine. So this sometimes this is also asked in exam. Before ending this session, this lecture on self-information, let us discuss one small problem over it. And what is that? Let us check that. If a question is something like this, that consider a fact, consider an instance where px1 is greater than px2, then number 1, which of the following facts, which of the following fact is true? So ix1 is greater than ix2, ix1 is less than ix2, ix1 is equal to ix2, and none of the above. So it is very easy to find out the answer for this. If px1 is greater than px2, it is a known fact that the amount of the information obtained for this event is always less than the amount of the information obtained for this segment. So the right answer is this one. So this is all from this lecture on self-information.